And hopefully the miraculous backroom team will be doing their magic, and our next speaker will hopefully appear.
I'm sure they're on it. There we go.
There we go. There he is.
Good afternoon, everyone. Good evening, rather.
How are you doing?
Not too bad. Not too bad. Good to be here.
I feel we've got to embarrass you a little bit online, but it seems that some of your pupils won an award quite recently.
That's
Very
right.
well
Yeah.
done.
Yeah. Thank you.
An anti-racism competition, I think, was it?
Yeah. So this is Emma, and she was in my class last year. I mean, she's still in my class, but in a different group.
Mm-hmm.
And she had built something for her health and citizenship class, and she was kind of focusing on environmental issues and so forth. And so she used computing skills from what she was seeing from my classes, and then tried to find a way to link it to what she was learning with the health class. And she did the project. It was fine. It was amazing. We all loved it. And then it just sat there. And we were like, okay, I really wanted it to be showcased somewhere because it was so unique. And she made a database behind the app, and it was really well detailed and a lot of interesting stuff. And earlier this year, I came across Raspberry Pi's coolest projects showcase. And they were looking for entries. And there was a pretty flexible kind of range of, what you can submit. And I'm like, oh my God, I got to reach out to her. This is it. Right? It's taken time, but here it is, right? And I had to chase her down. She's very busy. She's always, one of those students who's always volunteering for everything, taking a lot of initiatives, computing. She loves all the subjects. It's very rare to find a student like that, right? And computing is there, math is up there, and there's, PE. She's also doing things with art and music. And so finding her was really hard. And so when we got the time, I'm like, listen, promise me you will do this, okay? Because you have to try, right? Real victory is trying. Okay, that's the real victory. So please, let's go for it and see what happens. Because I think it's a great idea, and it needs more set of eyes to see it. And so she did. The tricky piece was recording the video for it and all that. And her work was picked up from thousands of entries. And part of me was not really surprised, and part of me was like, "Oh my God, I can't believe it."
Well, to be honest, you've introduced yourself because you were going to talk about cross-curricular projects. So to be honest, I'll just press the mute button and let you just crack on.
Sounds good. Let's do this. Right. Good evening, everyone. My name is Shashi Krishna. I am with the International School in Aberdeen. I kind of feel like the odd person out in some ways in such conferences because my focus areas, the subjects we all teach are the same, but the focus areas, the way it's assessed, the kind of priorities we have as a school are often different. Our focus is the IB program. We are unfortunately known as a school for expats, which is no longer true because we have a healthy blend of all nationalities, including local students coming in and joining us because we also offer the IGCSE. It's my first time with the IGCSE. It's my third year in Aberdeen. Hopefully many more amazing years here. Been around the block, 20 plus years in education. Going back to Patty's introduction yesterday, I started my career in Caracas, Venezuela. My first year teaching there computer science in the IB. And so my primary experience has been with the IB, but the computer science program has developed along the subject offering in many ways. And I've seen it grow over time. And part of the reason why cross-curricular in some ways has been a big thing for me for the last, at least a decade has been how I've seen computer science not really know where it fits, especially with programming and, hardware and networking and cybersecurity. And it's always figuring out which group do I belong to. And I come to the conclusion it belongs everywhere and it belongs nowhere. So it's kind of like this, 1 and 0 binary thing going on. So part of that idea was just to kind of think about, let me see if I can go forward. There we go. Think about how these things take on the shape of experiments, what experience I've gained from that, and what expectations from my humble perspective, I think this subject can kind of benefit from. So what I'll be kind of sharing, I'm hoping to do is kind of really go through the slides, show you what I've been trying to do in my own capacity, open up some, hopefully channels going forward to link up and kind of reach out to you guys. And then let's see how it goes from there. So very quickly, the one thing I always do in my classes, even before we start working with the content, is clarify what computer science is and it's not. And whenever a kid says, oh, I did this for my IT class, you can see my face turning red. I'm like, that is not IT, okay? It's computer science. It's the magic behind this magic. And so Clarifying that expectation makes it very easy for kids to actually realize how much of a superpower computing actually offers, not just in the practical work, but also in the theoretical stuff, the algorithms that mathematicians are coming out with. Now with GPT being a huge kind of source of intelligence, as it were, kids are asking questions like, how does it do that, right? We have this display outside our classroom. I should have taken a picture of that. One of my kids, one of my students built it with a Raspberry Pi, where it detects if you're a human or not. It tries to identify objects using kind of the teachable machine kind of an approach with Raspberry Pi and Python. But that's just it. Clarifying that has been a great kind of driver to how kids are conceiving this subject and finding links for it outside our syllabus. Very quickly, I'll go through some of these slides. I didn't know of a better way to do it. I'll just do it like an algorithm with step by step, and we'll take it from there. I kind of like this meme because it kind of captures what I'm trying to get to. When kids start learning to code, they kind of pigeonhole that and say, oh, I'm going to do this for my computer science class. I'm going to do it for a project. I'm going to do it for an internal assessment, and kind of take it from there. And then the knowledge is lost. And much like Emma's example, they don't really use that anywhere else. And so this is a good direction. A stage 2 is where they're using the coding skills to learn other subjects. And a few years ago, I found this amazing tweet where a professor in university was talking about how she was trying to use coding to teach physics. And that really got me thinking, like, yes, there's something here. We need to explore this more. And what the ultimate stage of that could be that once kids start developing these solutions, computational models, code-driven tasks that are derived from computational thinking kind of an approach in their other subjects, is that they can create, and this has already started happening at my school, small models, no matter how rudimentary and how amateurish, how simple, and how naive, rudimentary models for younger kids in other classes to use as one of the many resources they see. And that has been good, is that what they are developing today has become a teachable resource for a younger class going forward. And oftentimes these kids are siblings. So imagine a kid sitting in a grade 4 class, looking at something created by an older kid who's a sibling, and their eyes just pop up like, wow, my brother or my sister made that. And that kind of interlinking of grade levels within a school community has been an amazing thing to watch. So just to clarify, it's not about the tech. I will be showing you some examples of what seems like it's very tied into the actual platform, so it makes it more easy. But all these things have links that go to external places. These are screenshots of things that kids have built for other classes on their own. Like, I didn't assign them any work. It wasn't something they were asked to do for a grade. They just built it because that's how they understood that subject. And so to demonstrate their understanding, they kind of built based on what they were learning in my class. And there's a link on here which goes to my blog. Just making sure I can go back. Oh, sorry. How do I go back here? Oh, there we go. There's a link on here which when you click on it, it takes you to a blog site which has all the resources and stuff with what we've been trying. And a lot of it is research based. The stuff that you see here is based on how this kind of interdisciplinary, this kind of cross-curricular link can actually be beneficial for how kids perform in all these subjects. So it's not so much about, oh, they have to use this in a certain way. I mean, the sciences have been integrating for a long time. The math and the sciences have been integrating for a long time. The arts and music have been integrating for a long time. So this is not new ground. However, with computing being kind of the odd person in the group, this is a way to link it with what has traditionally been a tech-specific kind of approach, and thinking of how does this fit in here? What can we do to kind of make it a little bit more engaging, a little bit more, interesting, and honestly more informative and user-friendly as an experience. So part of my reading has just been looking at those things and thinking about how are people actually doing this across the K-12 curriculum. I'm sorry, I'm using the US terminology for the grade levels, from primary to high school, basically, the age levels between those two ranges. How are different subjects integrating different elements of computational thinking, different elements of, and in some ways, honestly, we do computational thinking in our own ways in all subjects, taking an abstract problem, trying to break it down to smaller problems, looking for patterns. But to embed the idea of code in any form, could be text, could be block, could be, using Makey, for instance, using Fraser's example from the previous speech. All these can have scientific, mathematical, even music-based and art-based links, which I think kids can benefit from as an experience. And how do they know that, right? And by they, I mean the teachers, other teachers. To clarify what it is we actually do in my classes, I've used, I had to literally beg for this, and I'm happy I did, because I have had to demonstrate, showcase what it is we actually do. My focus has been the middle years, which in the UK terminology is like S1 onwards, which is around the ages of 11 plus to 14. So that would be the middle school in our school, because that's where the flexible part of it is. We're kind of making the curriculum as we go. In the high school, however, we do the IB and the IGCSE program, so it's a bit more curriculum kind of regulated. It doesn't mean we can't integrate with that as well, but the middle school offerings give us a little more flexibility with planning, and I'll talk a little bit about that later in the slides, and kind of reaching out to teachers, having conversations. And part of that has been just sharing skills during inset days, where I'm showing them literally, here's what the kids are learning. Can you think of any way in which this can be used in your classroom? Or can you think of any way where they can demonstrate knowledge of what they're learning in your classroom using this skill, even if it's a small part of what they're learning? And that means making work visible. We have an internal chat for teaching resources and stuff in the school. And I'm always on the verge of spamming, really, showing them, look at what the kid has just made. Oh my God, I can't believe it. And that has been fruitful, because then kids have enjoyed that exposure in some ways. Oftentimes, kids are not very great at showing their work. They feel embarrassed, like schoolwork is not supposed to be shared. That's for school. But this has given them a platform to say, no, this is just as good, like probably what you would do on a personal level. So having those kind of conversations with not just the students, but also teachers have been extremely beneficial in kind of figuring out a plan for this. So here are some experiments we have tried, and this is just for this school year. We started doing some of these things last year. I kind of grouped them by the different subjects in which kids have built different things. So I'm kind of quickly going through that. The media studies is a classic example, because in some ways the schedule has helped, because the media studies also meets their kids once a week, although it is changing next year. We've kind of struggled with scheduling these things properly and ensuring that, and this I'm sure is a struggle all over the kind of, all the schools have the same problem. We're kind of figuring out a way to make it more consistent. 80 minutes in a week is not really enough to keep that consistent engagement going. And oftentimes we've had to kind of go back a few steps and repeat a lot more than usual, because, students have trouble recalling things. So the middle years basically linked in with the media studies to build different kinds of products. For instance, they were trying to learn about advertising in media studies and trying to sell impossible to sell kind of products. That included a car that doesn't go beyond 25 miles an hour, garlic potato ice cream. This is a broccoli chocolate something. And a couple of other kids in grade 6, which is S1, I think, were learning about origin stories of superheroes in media studies and what they should be focusing on. And also grade 8, which I think is S3, were reimagining the Midker Cross by Castle Street and thinking about how that space can be reimagined to make it a bit more Scottish friendly, a bit more culturally rooted, a bit more tourist friendly, a way to encourage local businesses, try to showcase culture and art. And so all these were linked to that. It's kind of unfortunate what actually happened, because interestingly, at the same time, Union Street was being discussed, and there was a panel meeting with all these, decision makers or whatever. And all they did was make up this huge sign called Aberdeen. And it was like, no, this was not what's supposed to happen. I actually shared a few of these links with the city council, and I never heard back because some of them probably were, I don't know if anybody even saw them. But the idea was to link them to something that the kids can relate with easily. And, they looked at the space and they looked at different ways to make it a bit more, culturally relevant and friendly for the environment. And so they built small little, VR experiences using co-spaces. Now, I have to clarify, this does not mean that co-spaces was the only option. We could have used anything else as well. But I've kind of handpicked these platforms because of the age levels and their gradual kind of, interest in more visual stuff and more kind of 3D based kind of, graphic design based platforms. And so that engagement was more important. What is interesting is all these platforms have both code blocks and text versions of the code. In time, I've seen them gradually switch over to text because it's just easier to deal with it. And that transition was exactly what I was hoping will happen, or we were hoping will happen. So media studies has been a good success story. I'm not going to show the whole thing for you in just respecting time, but please go through them. It has some interesting ideas kind of to take away. The other big collaboration every year, starting last year, was the history project. So every year, social studies / history middle school cover the transatlantic trade, where indentured servants were taken from West Africa, other parts of the world, to America to be on contract. And then when the contract was breached, they were taken to court. And all these dialogues, easily done in Scratch for people who are more familiar with that platform. At the end of the day, kids are then taking the journal entries, the court trial information, the historical facts from these subjects, and building an experience around it, which means now the same history teacher can use some of these really high quality examples as a way to introduce the topic for the next group. And that linking, that cyclical way of kind of making sure the knowledge is spread out a little bit more than the computing classroom has been amazing to watch. So that was another example of that. This was the first year we tried something with art. I'm kind of, my bent is towards art. I always think of things in a visual term, and I always want to see more fluidity in how kids express themselves using code. And so art is a natural extension to that. They built these selfie box portraits, and we have an amazing art teacher. She's fabulous. She makes amazing, projects come to life. And I was always, we are neighbors because her art room is right next to my classroom, and we're always talking about collaboration and ideas. And one of the things she mentioned was, listen, we are doing a selfie box portrait project. Why don't you just find a way to make a walkthrough and link it to ideas of growth mindset, how the kid sees themselves, how the kid sees himself or herself, their cultural setting, because we are an international community, kids come from all over the world. And oftentimes they don't have the connect because they've left many years ago, or they've never been there since they were born or whatever. This was a way to go back to their cultural roots and to identify and celebrate in some ways what is cool about it, what are some unique things about it, and so forth. And so here are 3 examples of where this girl here is from Nigeria. She captured the idea of jollof rice. She captured the idea of where she was born. She linked to the different cultures she comes from, and she had the little imported image of her artwork, literally photographed, scanned in from the art classroom. Again, using all code blocks, using selection statements, loops, what have you, camera angles, movement, the whole 9 yards there. This was also a new one this year, English. I've been fascinated by literature. I'm a big reader. I always we have a book club at school and all that. And so I'm always looking at ways to, because there's a strong element of narrative. Again, this doesn't have to be a visual thing. I'm just going back to my earlier statement of software is not a primary goal. You can do it just as well in Python using adventure-based, function-based, selection-based, kind of choice-based storytelling. Can also be used in Scratch, potentially also other platforms. So this was one way of doing it. So here what they were learning was magic realism. And so kids just either chose a chapter from the book to illustrate and to kind of make a visual experience out of it. The cool thing was some of the kids who had a bent towards literary writing and creative writing allowed the user to make choices of what should happen with the character's life. And that was amazing to watch because, look at this, a child who's 11, 12 years old is making those choices consciously by trying to go deeper into the text. So the software has become a secondary thing there. The person is, the focus is still on the literature. It's still on the novel they're studying. It's still on the concept they're learning. And so the outcomes are still very much rooted in the subject. Computing or coding is just a secondary way for them to demonstrate that. And when the English teacher saw this, she was really impressed. And so I want to keep that going. She's moving on, unfortunately, after this year, but I'm hoping that next year, whoever replaces her will still have some interest in these kind of collaborations with these kind of topics. Other miscellaneous projects, again, with code.org, we primarily work with CoSpaces because I've handpicked these platforms to be cross-curricular by default, right? Many people came to me and said, oh, we are selling you this, and oh, just throw money at us. And I'm like, no, we need something that automatically allows the creative aspect of a kid's thinking. It allows for flexibility in what they're building. It isn't too rigid with its design. Something a little bit more, open-ended with how kids interpret and use your features. And so that is a constant lookout. That's a constant research for me. But the kids have actually managed to find some links with what they appreciate in other subjects. So one kid here made a periodic table game where you basically learn about the different elements. You get to quiz yourself on that, and you get points for it, again, using variables and if conditions and functions and so forth. This other student made a story generator where you actually make your own story. You just make a few parameter choices. We were talking about GPT and I said, there's already story generators out there. If you're struggling for a mental block, you just put in some basic variables, some parameters, and it creates a basic prompt using which you can make a whole story out of it. And that really got him excited. And so he made a very thorough kind of example of it using these kind of tools. So again, all examples of linking computational work with what they're doing in other classes. How was the experience so far? Quick overview of that. I've always been conscious about not becoming a teacher mode only. Like, we don't want to know about what you're thinking. This is what we think is amazing for you. Just do it. We want to know what you're thinking. We want to see that we are designing the program and the curriculum according to that, and seeing how flexible we can be. These are some feedback. Overwhelmingly positive. They like the idea of choice. I like this one especially, where the idea of control. Oftentimes kids have a fear of lack of control. Someone is always telling them to do something, and so they're always looking for some way to control or dictate some aspect of that. And so giving them a creative outlet for that is a good way to implement coding as what is more for superpowers than coding, right? You can build your own world, do whatever you want with it. And so that allows them to be reflective about their decisions, understand the perspectives of a potential user, target it to that audience, and in some ways implement the basics of what typically happens in software development. And so that experience, that journey has been amazing. The other thing that came out of it was just time. A big demand for more time, and that's amazing and very refreshing to see. They wanted more than 80 minutes a week. We are working on that. We've actually fixed it for next year, albeit only for, we're doing a trimester-based approach. So I'll be seeing one group for 3 months, and then they move on to the other group. Not ideal, but still enough to build in some concrete concepts and still, aim for the big learning outcomes. Teachers matter as well. Oftentimes this is all the time. It's not a single person job. It's multiple teachers involved at all times. So I've had a chance to reach out to teachers who I know are happy to experiment, who are happy to take risks, like Miss Bonnard, who was part of the win that Emma was part of. She wasn't sure what she was doing. She's like, I'm going to let her do it. You will be the judge of what she's doing or not. I'm like, I'm happy to do that. And when I looked at the work, I'm like, this is amazing. This is exactly what you were trying to capture. And so those links with other teachers have been amazing. Everyone is for it. Time is, again, a challenge. Curriculum is not that flexible often. And so they have their own content to cover. And so even if it's one project in a semester, 2 projects in a semester, I think that's a good success story. And the fact that kids are able to showcase it on such big events is testament to how these things have a lot, value that goes beyond the classroom. There's a question. Maybe I can just hold on to the questions once I'm done with all these slides. A couple of unexpected random bonuses, which were not really planned. One of which was preschool taking on the story prompt creator and building a little activity around it. And that was really amazing. It was not expected. And when I shared this in the teaching workroom, this teacher was really excited. She's one of those pioneers. She's happy to take risks. And she got this app from me, and she was like, okay, let me just try it with my kids. And it was great. The kids loved it. They liked the idea of control. They were able to make choices. They were able to make their own characters. They had very specific opinions on what they wanted and what they didn't want. And that was great. So this, again, became feedback for the kids to actually build these devices, these solutions, and thinking about, oh, okay, so this was a target group. So what else could I have done to make it a better experience for them? So again, unplanned, but a good success story nevertheless. This, of course, was already mentioned, Recycle the Right Way. Emma built it for the health and citizenship class, not really knowing what to make of it. She wanted to implement something on her own. And this has been prevalent pretty much everywhere. I mean, there are kids who will take it on their own kind of initiative and build something around it without any kind of motivation or assignment connected to it, and find these links naturally. But that's a rare thing, right? So it's for us as teachers to keep helping them make those connections. So the links are always through conversations, through activities, through brainstorming, reflections, and just chats. I tell them programming is 90% thinking and 10% typing or doing, right? So think about what you want to build. Let's talk about it. And through those conversations, a lot of these amazing things have kind of come out of it. Where's the big picture? What's the next step for this? What I'm hoping will happen is that just like teachers now expect demonstration of knowledge through different ways, would be a video or a Google slide or a sheet or whatever, poster, a piece of code, something built around a computational model will become standard commonplace in a classroom. And if that happens, that I think is an amazing first step, where we are acknowledging that computational models, computing built apps are, we're going to be, teachers use it anyway. Non-computing teachers use apps and software anyway. Why not allow kids a little bit more freedom on building it in-house rather than having to use it as a consumer only? So flipping that a little bit to make them creators and not just consumers is a good next step. Other potential integrations happening next year. I've been really interested in Turtle Stitch. It's something I learned recently about, and we don't really offer a stitching class or a textile class per se, but we do offer a lot of 3D design and art and kind of sculpture and kind of pottery classes and 3D model classes. And so I want to see what can be done with that. I've been already talking to the teachers. I also want to do a collaboration with elementary, perhaps preschool or grade 1, where we're learning about sorting algorithms. Why not build a dance around it? And this is an example of what I saw once on YouTube, and I was like, that is an amazing example of how to connect the two dots together. And then, of course, using sheets to build custom. There are so many of these. These are just examples of what people generally take as naturally normal software, but you can extend it a little bit further. And again, it's not always about the software, right? Like going back to what I said, it's just activities, things that kids are doing where computational thinking, coding based thinking is already embedded in their actions. So just coming up to the time now, extended exploration, I'm happy to reach out. We've been trying to spread the word with computational thinking and kind of these cross-curricular links we've been trying at our school. Through articles, we have a podcast. We haven't recorded anything in a while. We hope to revive that next year. But that is something that we are trying to encourage more people to think about. And if you are one of those people who are happy to take some risks, kind of reach out to us, then it'll be great to have an inter-school kind of a collaboration with that. So that was me, essentially. A lot of things to cover. So I'm happy to take any questions.
Oh, Debbie, you're on mute again. There you go.
So good at this.
Right. Yes. So essentially what happens is that they cover the basics with me. They cover a few essentials. These projects are basically at the end of trimester kind of projects. So they've spent a few weeks with me learning the concepts, and then we find a way to link it to a project so that they're able to implement what they've learned. And then by the end of the year, they've gone through this 3 times. The hope is that their project becomes incrementally higher quality as they go, because they're learning more things with me.
It sounded great.
See the question at the beginning there, Shashi, is it easy to get your colleagues on board? Because I have to say that whenever we've tried, we've had problems getting some of our colleagues to work with us. Maybe they don't see the bigger picture. I'm not really sure. We've tried it even with, like, me and Brendan with the Lego project, because
right.
A lot of the Lego projects to do with, we've had natural disasters and stuff, and we just can't get other departments, to see how this is just natural, ideal. So how do you persuade them? How do you win them round?
It's been a challenge, I'll be honest. And going back to this question here, how many staff do we have? You're looking at them. So I am 1 and 0 at the same time, equivalent to 10 in some ways. Although I must say that's changing, because we're getting a new person next year who has a background in design tech. Part of the problem has been just hiring people who are confident with this kind of a subject, and kind of happy to take risks and happy to let go control sometimes. And so it's been conversations, just relationships, making sure that I told you we have a book club, and a bunch of the guys are there, and we usually read a book once a month. And part of the conversation has been just encouraging them to try it. For nothing else, just try it. If it doesn't work, it doesn't work, but at least you have data as to why it didn't work. That way we can customize it a bit more to make it work for you. And I would ask them, aren't you bored looking at slides all the time? And they're like, yeah, we are. So why not try a little bit of, some things that you can click on and make noises and bells and whistles? Why not? And they're like, okay, let's give it a shot. So it's all about that marketing, right? Upskilling the staff in some ways. I run a coding club as well, and we've invited teachers to come and try an hour of code during Hour of Code festival, and that was really good. People who had never known that they could do this were like, I've broken something, and they were really happy. They had a wonderful time. We want to extend that to parents as well next year. So a couple of sessions where parents can come in. They're going to pick up the kids anyway. Come in, try a few coding things. And so it's a way to make it less scary as an experience, that yes, this is a tool that you can actually use. And why not? Because kids are already learning it. You might as well use it.
Yeah.
So I hope that does that.
Tony or Brendan's in there. Do you run any upskilling for other teachers in your school? You've just said yes, you do, but it's fantastic. You're also upskilling the parents.
Yeah, oftentimes when we have parent conferences, kids are amazing at sharing their work with their parents, right? They're like, what was that? I don't know what he's talking about. And I'm like, dude, you haven't told them. Oh my God. And so it was a way to clarify that misconception. Like, this is what the kid is doing, right? You should know about this. You might not be able to help with it, and I tell them you can help them by talking to them about it, because communication really matters. Please talk to them about your work, give them ideas. And I tell them that if you haven't spoken to your parent about this idea, that I don't want to hear it. Like, tell me you've shared with them. And so that is a good segue into the IGCSE and IB, because there's a bit more kind of challenging, more high quality work expected there, and this is a good way for them to think about those terms, and not just about computer science, but just any subject, because the more you talk to other parents, other peers, and other parents, you get better ideas. So it's an ongoing work, but incrementally getting better.
Yeah, I think it's fantastic. I really think it's fantastic, because we're telling children all the time, it does not matter what field you go into, you need to have some coding skills, some real IT computing skills, and you're just bridging that. It's absolutely fantastic, I think.
Absolutely. And I tell them, listen, you don't have to take computing to learn coding. Don't feel that I'm going to feel bad, because you look at GPT, it's a classic example. We talk about ethics, we talk about AI, we talk about how machine learning is basically trying to manipulate you in some ways. You have to know how the enemy works to be able to work with it. And so that means being able to see a bunch of lines, a bunch of logic. And again, it's about the logic. See, the language takes a back seat, right? As a human being, are you logical about these things? Do you understand the steps that go into making these things work? And that is the real goal. That if I can help you break down that and make it a little bit more logical for you to approach and solve problems, I think that's the battle won.
Definitely.
Yeah. Great. Me hoping to make it time. That's good. Just 2 minutes over. I'm good.